Okay. Hello everyone. Sorry for coming late. I'd like to give you a brief introduction to Ruby modeling. Uh, Today I will show you how to combine how to link the Ruby to Python and how to use them to model a real world problem. The first problem is why we need to use Python. Actually, Ruby customers can use different interface. In almost all programming languages like Python, C++, Java, MATLAB, and so on. But Python, we recommend you to use Python because Python is simple to learn to learn from new group users, and Python provide us some special features and make it easy to build a model. The first step is to install the Groovy. I don't know if you have already installed the Groovy in your computer, but I will show you a brief introduction. First, you need to log into the Gurobi website and get a license, get an academic license. There are different licenses for you to use. You can use a local license just for your desktop, and you can use a web license. This can be used in multiple platforms. And after installation, we also need to install packages on install Python package to use the Groovy. I recommend you to use the Anaconda because Anaconda provide us tools to install the Groovy tool. And with the Groovy package, we can use our Groovy solver to build and solve a model. I'm going to show how the Gurobi works in optimization. First of all, we have a real world problem, and we use a model generator to generate to transfer the real problem into a model. And then we can use the Gurobi solver to find an optimal solution for this model. And the solution is transferred back to the planning system or other systems for future analysis. And the cycle repeats until we get a good enough real solution. And after that, we can solve our real world problem. And we also have some concepts for Groovy. The most important parameter attributes. Parameters is tell the Groovy how to run the problem, and the attributes is the problem looks like. You can look at the right two figures. We have a model have attributes and parameters. Both all the contributions, variables, and some special sets are all attributes because they are part of problems. And the parameters is based on the environment and the model itself. For the whole container, we have global parameter settings. And for each model also has its own local parameter. So this is but when we establish a model, the model will copy all the global parameters to this model. So we must set the environment parameters before we set up. And these are some examples for the attributes and parameters. For example, we have some global functions, the set parameters, the read, and some objects like model, the variable, and constraints. They are attributes and these are parameters. Or by setting parameters, for example, we can set the time elimination. Set parameters tell the Groovy solver you can use at most 60 seconds to solve this model. And this is a global parameter. And the last three, the model time limit, is a local parameter. It is just used in this model. And for variable or variable and constraints, it also has its own parameters. And we also have some important methods or functions. For you can see by with each model we can set the objective function, and by using the optimize we can solve the total model, and it will return us a good solution. And we can also set the model to the initial state, and you can try it again, maybe. And there are some also methods can be used after resolving a model. For example, we can print the attributes to the solution. For example, what's the variable values resolved. And we can also print status, print quantity, and we can also get vars, get constraints with this method. We can know how we can know the solution the our return to us. And in next step, I will let you know how to create and solve model. First of all, we need to create all variable objects because of we can run the optimize. One good news that our Python API supports the expressions similar to the mathematical notation. This like you said, we transform a math formulation into the programming language in Python. So we can be clear when we create our model. And this is an important step. An example. Like you said, this is an optimization problem because and it has the objective functions to maximize the formulation, and it also have two constraints. With the objective function and the constraints, we have three binary variables x, y, and z. We will operate these variables and try to maximize the objective function and to meet the constraints. This can like you can see, this is a linear mixed integer program, and one of the problem type that the Gurobi solver can solve. And to transform this object to transform the objective programming language, we can use several steps to do that. First of all, we create a model. This is the initial step of all of the whole model. And we create with this line, we create a Gurobi model named M, and we add variables to the M. You can see we use the add vars to add variables for x, and in this function we can set the variable type. Like we showed before, the x is a binary value, and the type should be GRB binary. And we can also set a name for this variable, and we can use this name to find the variable we established here. And we add x, y, z variables to this model, and we set object functions. Like you can see, we have already created the variables, and we can use it here. The objective should be x plus y and plus 2 multiple and 2 plus 2z. in the last parameter is to set if we want to maximize the problem or minimize the problem. And by this line, we set the objective function. And the next two lines is to add constraints. We have two constraints. We can add them one by one. Like you can see, the C1 is x plus 2y plus 3z less than 4. And the second constraint x plus y larger or equal to 1. You can see the Gurobi for the Gurobi expression is very like the Python math expression, and with all the variables, objective function and constraints, we can solve the model by the optimized function. With the optimized function, we can solve the model. And before that, I can show you an example by and I am using my remote computer because I don't have the Gurobi on my laptop. First of all, we import the Gurobi package, and the second step is to create a model named M. The next step is to add variable and set objective and add constraints. Finally, we can optimize the whole problem, and it will give us a optimization result. Like you see, after the solver, we have the x and z equal to 1. And let's go back to our slides. And I cannot introduce all the functions, attributes, and the parameters one by one. But if you want to use, you can use the help function to help you learn what the meaning of each attribute and parameters. For example, you can help model and to check what is the model object and what is the variable object, and you can also check what the function or method is, and you can also check the meaning of parameters. After the introduction, I think you already know how to set a simple optimization problem. But I want to give you some more tips because sometimes the program will be very large and it may have thousands of variables and thousands of constraints. You don't want to insert them one by one, right? So we have the group. We provide some special features to help us establish the model. For example, we can have a list of tuples. I think all of you know how Python works, so and all of you know what the list is. We have a list of cities and we have a list of routes. With the list, we have 4 cities A, B, C, D, and between each city we have routes. So to establish a Gurobi model by the list, first of all, we can just use integers to create to add ones. For example, the add was 2, 3, and the name x. We create 6 variables in total, from x00 to x12, and we can also use the list. We already have cities, so we set the rows are cities. The rows are cities and the column are cities. So we have 4 cities. So we have 16 variables in total from YAA to YDD, and we can also use tuple list. Remember the roots with the roots with the list roots we can establish 5 variables in total because we have 5 elements in the list. And we can also use an expression in the Gurobi functions. For example, we can say when only when I not equal to 2, we add a 1 to it. And so we have 4 variables. W0, W1, and skip W2, and W3 and W4. We can also use this in the constraints, not only in advanced. So we can add constraints by using the math expressions and the list we said before. And you can see with this line, for all the ij in roots, we add a constraints. And we also have a quick sum function. Quick sum is very like the sum function in Python, and we can use the quick sum to add some formulations or variables, and to, for example, we set the objective function as the sum of all the cost of each x. As the last, I want to show you some examples of parameters. I cannot show them one by one, and you can learn them by yourself. But they are important in Gurobi solver. The parameters is, like I said before, we tell the Gurobi solver how to train, how to solve this model. For example, we can say the MIP focus to let the Gurobi know or focus on what. For example, finding good solutions, improving lower bound, and so on. We can also set some parameters to limit the performance of Gurobi. For example, we can set the MIP gap to let it know when the gap is under 10%, we stop the solver. And we can also set a best objective law, and to let the solver know when we find a solution better than the target wall, and it will stop. So with these parameters, we can operate the Gurobi solvers to let it get a solution that you want and or you can accept. And there are also some other parameters. For example, the solution limit. Just when it after it finding fail solution, it stops. And you can also, for example, the iterations limit. After with this line, after you type 1 million iterations, we let the solver stop. Definitely, if it already gets a good solution, it will stop before we get the limitation. This is my introduction to Gurobi and Python. I hope this can help you some. Do you have any questions?
Yeah, could you open your team real quick? So I post the website for you. So
sorry.
So open the link address. And this is the website, and for those scroll down. So these are those problems that Gurobi solver can solve and recognize. So mostly this linear, mixed integer, quadratic. If it's about quadratic, it may have a use. So I wish everybody, when you use it, to make your problem into either linear, mixed integer, or the quadratic. Okay. So that's my comment.
Yeah, my good thing is that compare with MATLAB. Okay, what about algebra?
And my first.
Oh, and mathematics, yeah. What about algebra? Compare with MATLAB.
Ruby has student lesson.
MATLAB is good.
I mean, the Gurobi is a commercial one, so it will be wide. I think in commercial use for those companies, they won't let you use MATLAB instead of Gurobi.
No, I don't think so. Dr. Fan, do you have any comment on my question?
MATLAB is a toy, and Gurobi is a true car. It's like you play Cardincho, and you have a Ferrari. That's the difference.
Yeah. Anyway, I think you know that probably it's a bit. So what type of problem that the MATLAB have to solve in the Gurobi? I know that okay, you're making some kind of large scale network, and so for example, okay, for the large one, MATLAB cannot handle that. And some other things you mentioned that you can't use Gurobi instead of MATLAB. Can you give us some kind of example?
I mean, most of the
speed, of course. Yeah. So my feeling is that okay, maybe I mean this is show it yourself. Maybe when you do the small work at your algorithm, maybe you can kind of using the MATLAB to quickly get the result with a small scale. And when you come to this kind of large one, you will check to change your MATLAB to Python and then find it again. So I think that will be a quicker way to solve the problem because of when I'm still programming, okay, I found sometimes okay, when it comes to the network slightly larger, the network cannot go. Take a long time.
Oh, one more comment. So the other way is the Gurobi also support import from matrix. You can import those constraints by matrix. So once you have MATLAB, you can export a matrix, then plug in the matrix to Gurobi, then it will solve.
Yeah. Anyway, so maybe slide first let's talk about feature and the starting presentation, and maybe before you send to the final version, you add one slide with all the questions, compare with MATLAB and Mathematica, what is the advantage for Gurobi, and maybe you can Google and try to see the comparison that and
Okay, I will.
Any other questions?
So the website, because I can use some tutorials for the functions of this.
Oh, you mean this website?
Do you have a documentation at the top? They go to documentation. They go to documentation. Very top. It's small. Yeah. They give you some quick start examples. Here you can use C++. They also have API connection. Yeah, that's a good thing. So you can there's some example for reference menu. You can use that as a reference. Yeah, it's pretty powerful, and I guarantee that it will make your life easier when you do the modeling, because it supports the linear expression. And I believe for MATLAB, sometimes you have to instantly call it every time, right? For every line. Gurobi in Python at all. Yes.
Yeah.
Whatever you do there.
Any other questions? Okay, so the conclusion, I will put the slide as well as the video on the website. The conclusion is that okay, in the future, before the deadline, don't tell me that the computer cannot solve the problem. I don't know. I try to feel that you wait for this long kind of time for this kind of simulation stuff. If you are in the optimization, other machine learning is not a problem. If you are working on the optimization and you tell me the network, the computer is not good enough, it's easy. You try to